Okay, cool. Yeah, so I'm PJ or Peter John or whatever you want to call me, actually. Like, I don't really care. But Pajapples, apparently that's a thing. Because of, I'm not going to go into it. I always go down that road. It's like just a deep hole of things. Anyway, Twitter, PJ Apples. Tell me if you like my talk, if you hate it. If you have some feedback, that's always awesome. Hit me up, and I'm the mobile engineering lead at DVT. And today I'm going to be speaking about creating custom machine learning models with AutoML and MLKit. So just a little bit about me. I run GDG Johannesburg with some other humans that help with this conference. I mostly do Android and iOS development, some Google Cloud, and we do a lot of stuff on Firebase, and there's a random South African flag. So what I'm going to be focusing on today is two parts, right? One is AutoML, which is a Google Cloud product that actually moved into the Firebase realm, which went part of MLKit. This is because they decided to help us create machine learning models that can run on mobile phones. And then I'm just going to talk about a few things over there, and then I'm going to tell you about some UX inside of the Android ecosystem with this whole thing. So AutoML, what is AutoML? Firstly, I'm going to go to machine learning. And this was me once upon a time. I'm like, hey, I wanted to do some cool machine learning. And everybody's like, yo, you got to go learn that maths. And I'm standing there, and I'm like, I should learn more maths. And then I realized that like maths is not that great, so I decided, let me search the web and find if there's a tool out there that can do this without me having to learn all the crazy math. And then I found this thing called AutoML, and I was like, oh my goodness, this is great. So what is AutoML? So in terms of machine learning, there's like two spectrums, right? There's the data science people that do all the categorizing and all the crazy stuff, which is the hard one, right? Then there's the other part where you get companies like Google and, I don't know, Amazon and Azure and all of those people that provide like pre-trained models for us to use via APIs. But sometimes those don't actually give you what you actually want. So you can't go and you can probably retrain those models if they make them available, but you kind of want something specialized to your application, let's say. But now there's a part where you don't have to write any code because it's an API, but then there's another part where you have to be pretty hardcore with TensorFlow and do all the writing and all the math. And then there's Cloud AutoML that's kind of in the middle where you can create custom machine learning models, but you still don't have to do all the math in the code, which is kind of great. Cool, so I'm going to jump straight into it. So this is AutoML on Google Cloud, and it's pretty much, there's actually four of them. Four? Three? Four. There is four. So there's AutoML Vision, there's AutoML Natural Language Processing, there's AutoML Translate, and there is AutoML Tables. These are all different types of products within AutoML to create models. But today I'm going to be focusing on AutoML Vision because it's kind of like a more visual, excuse the pun, a more visual way of representing this product itself. So what I did, so context, I have this random app that I'm not going to tell you about because you're going to go download it and you're going to think I'm a bad app developer. So it's an app that has to do with plants that I wrote like 6 years ago, and it was, yeah, I wrote it about 6 years ago, and I haven't updated it for probably about 4 years, and it's kind of like there in the App Store. And what it does is it pretty much helps botanists that are out in the field go and pretty much gather data about specific plants. One of the things is that they kind of have to go and they have to like look and see, is this the specific plant? A lot of the plants look exactly the same. And what they do is more on a scientific level to the point of where the plant, they don't just name something like a rose or I don't know, another plant. I have no idea what other plant, chrysanthemum or something. They go and they do the whole scientific thing, and you can have like 10 different types of roses, right? And then they look at a whole bunch of different things. So it's like leaf shapes and how they have different bases at the bottom of their stems and stuff like that. And this was kind of part of what we were trying to solve within this application. And this is how we kind of like got to this example over here. So we have some images, and what we want to do is that we actually want to classify, we want to create a machine learning model, a custom model, because the normal ones don't work for us, to identify specific plants, plant shapes. So specific plants and then plant shapes that they have. So you can see over here, some of them have a hash state base, and others don't. So we have, this is a very small data set, so I just did it for this presentation, but just to give you context, a hash state base is kind of like almost a flat leaf thing at the stem over there, and the other one is like round, as you can see. So what you do, you go in AutoML, you throw some images at this thing, and there's a button at the top over there that says train. You click the train button, and then you say start training. And what it will do is it will go to the cloud, and it will pretty much create this machine learning model for you. You don't have to write any code. You don't have to do anything. And at the end, okay, that's awkward. Okay. It's the AI. Still good. What is happening? Okay. Yeah, it's still going. So we click train, and we train the model, and we go away, and we have a coffee, and we come back, and the machine learning model is trained. And then we pretty much click on our predict, and what predict will give us, it will give us two different options. It will give us a place where we can take our image and we can throw our image at it to test the actual model. But what this will also do is it will generate a RESTful API for us. So you pretty much have your machine learning model that's now being served in the cloud, and it will generate this RESTful API, as you can see over here. It also will create some Python code for you that you can pretty much just chuck into a client if you really want to do it that way. And something that's actually new in AutoML in Google Cloud is that now you can also export them for mobile using the edge devices over there. So it will actually give you an offline model that you can also create, right? So once upon a time, I'm still interested in it, but like I was very interested in this product, and I was like, how do I get it into mobile apps and stuff like that? Then I wrote an article. If you want to go read it, how to get it into an Android application. This is based on the RESTful API. So what are the pros and cons of using the Google Cloud one, right? Or the pros and cons. So you can create your custom machine learning models without any coding. That's pretty much what I wanted to do. It generates a RESTful API for you. Again, this was pretty awesome because all I needed to do was chuck it a byte array or the image, which is a byte array, and it would pretty much give me it would predict what this image is, and it would tell me like it's confident in a specific range. Like it would be like 70% confident that it's this, and all of those type of things. You can now obviously export this thing for mobile, so that's also great, and it's really, really easy to use. The only thing is that there's no way for you to really do any kind of A/B testing for this specific thing. So you can't try and test your models. You pretty much have to deploy a new one every single time, train it, deploy it, which isn't really great, especially when you have stuff in production. There's no way of also dynamically serving it, so you pretty much going and you just, that is the API, and sometimes the names, if you don't name it correctly, it will generate random names for you, and it would actually then change your URL even, which is also not great. And then there's no way to like easily track this thing with analytics, like auto analytics. You actually have to go and write your own analytics within Firebase, within your application to do this. So that's kind of where, and this was all focused for mobile apps. So this is kind of where AutoML comes in with MLKit. So what I did was, because at the back of Firebase is pretty much Google Cloud, you can use the same data sets, you can use any kind of data sets that you create, you can use within Firebase, it will show up in MLKit console, and you can retrain the models over there. So what I did was I took exactly the same thing and I just retrained it. It then retrained within Firebase, and it gives you something like this, and it says, hey, there's a data set, it has 3 labels, and there's 20 images in there. What do you want to do with it? It also gives you a confusion matrix to tell you about false positives and false negatives to figure out, because what happens is you give it a whole bunch of images, and it takes a percentage of those images. So let's say it takes 80% and trains the model on that, and the other 20% it actually breaks down and uses it as testing data to make sure that it can actually recognize what these things are, and then it obviously ends up with a confusion matrix to tell you where it kind of like is struggling. It can say, I can 100% do the one at the bottom. I don't know how to say that word. And then the other one, over there, it says, hey, there's a 50-50 chance that it could actually mess up these hash state bases with these images. And then within the console also, you can drag some images, and the images, it will pretty much give you some kind of prediction over there. So you can put your image in, and it will say, hey, this thing is this specific plant with this specific confidence. This is quite nice just to kind of like test your model and see if it's like working correctly and how you actually want to, is it actually giving you the correct results before you actually try and put this thing in an application. So this is kind of where the magic happens. So with MLKit, you kind of have like 2 options. Once you say, cool, this is my model and it's trained and this is the thing that I want to use now, I've tested it, it looks great. MLKit gives you 2 options. You can either download the model, or you can publish the model. So what the publishing model does, well, the download model first is pretty much just downloading it. You're going to put it inside of your application. And then you're going to write some Firebase code that we're going to go through a bit later to just to pretty much like use the model offline in your application, which is great. Publishing within Firebase, though, allows you to publish the application almost like a RESTful API, but what it does is that you can actually use the Firebase SDK to get your model and download it straight into your application, almost like it's offline. So what you can do is it kind of like serves the model to you inside of your application, and then you can actually use that model at any time. So this is kind of where it gives you that flexibility to be able to have the model at any point. So Android code, you guys know dependencies. We just throw some dependencies in our Gradle file. And what we're going to do here to pretty much create our local model, to use our local model, you download a little zip file, right? And then you give it a name. Your model, you need to give your model a name, and then it has a manifest file that pretty much creates the link into your Firebase model that you downloaded. This is weird. And then you pretty much write 3 lines of code to get an instance and register your local model. And that's pretty much it for that. For a remote model, it's a little bit more code. So you're obviously going to do something very similar. You're going to create a builder, and this builder is kind of like a few conditions where you want to say, I only really want to download this model from Firebase when there's Wi-Fi. I want to make sure that that I do enable updating of this application. So again, when we think about these type of applications, we think of like Africa, right? I think Alex mentioned it earlier. Like when you're in another country and you're using an application, they have like unlimited data and all of those type of things. In South Africa, we don't have unlimited data, so we don't want people to be downloading models all the time. So we can use some of these conditions, like require Wi-Fi to actually pull these models, helps the user not have like data problems. And then we're pretty much going to register it, and exactly like the local model, and then we're going to have a little download function that will pretty much download our specific model. So then what we do is we create a labeler, and the labeler will say, hey, you can set a local model and a remote model. So what it will do is that if you have the model inside of your application, it will use that model until there is actually Wi-Fi for the thing to be able to download the external model. And we pretty much create an instance of it. There is a threshold over there. So what the threshold is, a confidence threshold. You can say, if anything is less than 0.5, which is 50%, then don't even try and predict it. So you can predict, well, don't give me the answer. So it will kind of say, hey, there's these labels that it has, but this one is lower than 50. Don't actually give me those labels. Only give it to me of a certain threshold. Then we can pretty much say labeler.process our image, and it will give us a whole bunch of labels. It will tell us this is a specific thing. It will tell it has a hash state thing, and it says with a confidence of 45% or 80%. And that's pretty much it in terms of using it within with your Firebase SDK. So what's cool about using the MLKit is obviously it's we can use it offline. It is bundled with the application, but that means that our application is obviously going to be larger. So you kind of have to look at your pros and cons here and say, do I want a really, really large application, or do I want a large application, which is really something that people don't want, especially in Africa again, people downloading your app. If it's too big, it's not really great. Or do you want an application that can be dynamic, but then it's going to be using people's data, right? So it's a pros and cons. And you can obviously, you can serve these models. Well, what's cool about serving these models is that you can always update these models at any point in time. You don't actually have to update your application at all. So you can now serve a model from the cloud, and it will pretty much just update that model locally on your machine, on your user's phone all the time. Yeah, and like I said, it makes it's cool. So you can actually, it makes it smaller if you're using served models versus actually having it in the application bundled with your app. So some cool things that I mentioned earlier on, again, was kind of where Firebase kind of shines. So we can have this thing, well, I think Alex also mentioned A/B testing, but where we want to kind of test a model in certain areas. So let's say I want to test a new model in, I don't know, in Europe somewhere versus in South Africa. So I can use something called remote config. Does anybody use remote config? Okay, cool. So yeah, you can use something called remote config, and remote config can pretty much help you swap out your models in real time. So I can say, okay, cool, I have 50% of my user base is here, and another 50% is over here. I want them to use a specific model, and I want them to use another model, and then I can use analytics to be able to check and see, hey, what is the use case here if I'm adding new features to that thing. Or I'm adding new, let's say I'm increasing my model size. Is it having an impact on these users versus these users are doing great still with the old model? Also, are they actually getting any value with the new, with any of the new plants or something that I've added into that specific model? So that's kind of cool. Remote config does that really well. And Firebase Analytics helps you actually monitor that and actually gives you feedback in terms of that application. Cool. Another thing is that all of this also works on iOS. So they've built some really cool SDKs. You just kind of install a pod, and you also write 5 lines of code, and it gives you the exact same functionality. So it works on Android and iOS, which is great. I did find some bugs. So I do have on my GitHub, I'll share my GitHub link at the end. I do have examples of both of these. If you want to go try it, you can just pull the code. For Android and iOS. I did find some bugs in the documentation, though, that I should probably, I don't know, tweet people or something. That where on the iOS side, there was some stuff that was a bit inconsistent. So just kind of watch out for that if you are going to go and try this out afterwards. So Android. So this is kind of to do with performance, right? So I'm going to play this video on the other side. I hope it plays. Cool. So what I'm trying to show here is that on the right-hand side, is the AutoML REST API. And you can see I clicked, this is all kind of like real time. I clicked on upload image, and now it's going to go and find it in the cloud somewhere, versus the other side, which is an offline model. And you can see how fast it actually predicts the specific thing. And it finally came back with the thing over there to say, hey, this is like 51% and stuff. So what I want to show over here is that with the RESTful API, I'm giving it the worst case scenario over here. So I tried to not use this model for a very long time, because what it does, it actually uses cloud functions. And in the background, cloud functions kind of have to start up. So like, as soon as you hit it for the first time, it will go and it will say, I'm doing a request, and it will wait. And then the cloud function will start up, and it will kind of like boot up and boot up and boot up. And eventually it's like, cool, I'm ready, do the prediction and send it back. Once the cloud function is actually like up and running, it will predict much faster. But you can see that obviously an offline model obviously works much faster than it would do in a RESTful API. The other thing is that you need to kind of think of the user experience. Like, what do you want the user to actually experience once they clicking that button? Do you want more accuracy, or do you want, because you will get better accuracy probably in the cloud, because you can train the model all the time and you can make it bigger and bigger and bigger, or do you want it to be specifically like, hey, I have this specific model and it's on the phone, and I can't go out there and just like say, hey, I want to try something new now. We can do it with the serving of models from Firebase, but again, that's like people still having to download models, requiring Wi-Fi, all of those type of things. So you kind of just have to, when using these APIs and these SDKs, you kind of have to just think around which one do you actually want to do. Sorry, like that one just repeats the whole time. So yeah, it's like a strobe. Cool. So the other thing is with AutoML, it does cost money, right? So there is a free tier. So they were very generous back in the days when it was still in alpha and beta. And it recently went, I think it was actually like 3 weeks ago, it went like general public release. And now it's pretty much like they give you, I think you get like maybe 5, you get 1 hour, you can train the model for 1 hour. So once your model starts getting big, you're not going to get the best accuracy if you're only training it for 1 hour, versus obviously if you pay, you'll get the things. But I think the tier is also that you only get like 5 1-hour slots, and then after that you also have to pay. It's not very expensive. I think I pay like maybe $2 a month to train models, but also sometimes the data sets are not really big also. But yeah, just a reminder, you're going to spend money, there's money involved. It is what it is. Cool. So just something quick, I wanted to share a use case where AutoML is actually being used out there in the world. A lot of the applications that I build are very specific to myself, and there's not too many users actually using it at the moment. So I don't get the vast feedback and stuff, but there are people that are using it for their research, especially out in the UK. There's a lot of people that are actually using this product. And yeah, I just want to share a quick video.
The main challenges facing wildlife today is habitat loss, climate change, and threats from the illegal wildlife trade. ZSL's mission is to create a world where wildlife thrives. We work in over 50 countries around the world where we empower and inform people to help stop wild animals going extinct. We have been working with Google to look at how we can use Cloud AutoML to really make a difference.
We use camera traps to monitor the state of the planet. They are tiny little digital cameras hooked up to a little motion sensor, basically. So when an animal walks past, they snap a little photo, which you can then retrieve at a later time. As well as telling you about how abundant different species are, they can also offer behavioral insights as well.
One camera trap study generates hundreds of thousands of images. So over 6 months, you might get 500,000 images that you need to sort through and analyze.
You've got to go through every single image. You've got to label them, the time, the date, what it contained, which camera it was. At the moment, it takes months.
If we can speed up the analysis from 6 months to just days, that's revolutionary in our conservation efforts. Google Cloud AutoML allows conservationists who are non-coders to use machine learning to create image recognition models to identify species in camera trap images.
These are images that I have labeled, and they're going to teach the AutoML algorithm what different species look like.
If you can just AutoML it, you could go, show me the images that are empty, show me the images that have the animal that I'm interested in. You can actually use your scientific research and conservation time to do conservation rather than doing data analysis.
We might use the data to actually influence policy change or conservation action. AI is going to play a really big part in collecting all the data together from wildlife conservation sites around the world. And if we do that in real time, we can use AutoML to really monitor the pulse of wildlife across the planet.
So what I wanted to say is this is kind of a really, really cool use case. On how this actually gets used, which is really, really awesome. There's quite a few other use cases where people are using it, and even in my case at the moment, so the machine learning model that's being trained now is actually not even being trained by me now. It's actually being trained by other botanists that are actually training the model because they know the plants best, right? I don't really. You saw I was like, hey, I don't really know what that plant's name is over there. They know it really best. They're creating the machine learning models now, they're training them, and all I'm doing is that I'm utilizing those models and putting them in the apps so that they can actually use it. This is something that is quite cool because sometimes we kind of just work on products that for companies and all of those type of things. Collaborating with other people and working on these type of projects is really cool. One of the things, though, with AutoML is that a lot of people come and they ask me questions about, so how do I change specific things? How do I change the hyperparameters? Like, how do I make it more accurate? How do I change the algorithm that it's using? I don't want it to use a linear regression. I want it to use some kind of tree algorithm, or something like that. And the short answer is that you can't at this moment in time, which kind of limits the tool, because when developers or people that are specialized in this field, they actually want to use this tool because they're like, this is really, really awesome and quite advanced, but there are a few things that I feel like we can change to maybe optimize and make it better, but they actually can't at this moment in time. So those are kind of some of the downfalls of the tool at this moment in time. But it's still a great tool, and we've utilized it really, really well. And yeah, so what I wanted to say was, go try out the tool. Let me know if you have any questions around it. If you have any questions on Firebase, about using the MLKit in Firebase also, let me know. And yeah, if there's any questions, I'm free to take questions now. Thank you. Yeah.
What algorithm does it use in the back end? Thanks. Sorry, what algorithm does it use in the back end? Or does it auto-generate?
So it uses, it doesn't tell you what it uses. So it could use any algorithm. It uses what they think is best for the data set. So like I mentioned, that there's different types of AutoML. So there's the AutoML Vision, which is for images and the natural language processing, translation. They use specific algorithms based on what type of model you're trying to create. If you're but they don't tell you, and that's kind of the thing that a lot of people are asking for. They're like, tell me what kind of algorithm I'm using, and that would actually make it much better for us to be able to utilize this tool to its full potential. Yeah. Yeah, over here.
So I'm especially curious around IoT and edge devices. Yeah. So around the models that we're going to export onto the edge devices, are there any specific models right now supported which will expand, or is it like how it is right now?
So at the moment, you can export for edge for IoT devices. It's all TensorFlow Lite models that it exports. That's the only format that they offer at the moment. They don't offer anything else. But I think the team is working on being able to export for any other type of models that you want. One of the questions that I had also around, sorry, there was a random thing. One of the questions I had was kind of around iOS models, just because Apple also has a tool very similar to AutoML, and it creates Apple-specific models that are more optimized for iOS devices versus, and I was like, can we not convert these models to that specific format? And they kind of were like, no, because Apple just like kills everything. They're like, this is our API, we're not gonna let anybody touch it. So, but you can use TensorFlow Lite models on iOS devices, which is great. They're just not gonna be as optimized just because they're gonna be larger and they don't actually use Apple's hardware specifically because they have specific silicon that they make to run those other machine learning models. Cool. Yeah, I don't know.
So just a question that you sort of touched on there about sort of interoperability of models. I mean, obviously, Microsoft have their own ML and that. I mean, how does, I mean, I'm fairly new to this as well, but I mean, if you've spent a lot of effort training a model on Microsoft platform or a Google platform, do you have to do the same in both? Can you take a model from one environment and use it on the other?
Yeah, so with Microsoft, they actually, TensorFlow is a first-class citizen on their platform. So they actually use TensorFlow to train their models. So you're pretty much getting TensorFlow models at the end of the day. They don't have their own way of doing it, but they do support other formats from like PyTorch and all of those. Any kind of format that comes from there, you can get those type of models. But TensorFlow is pretty much a first-class citizen on the Microsoft platform that I also learned like a week ago. So that was also awesome. And yeah, so I guess depending on where you train it, it just depends on what they offer. I don't know about AWS. I've never tried to train anything on AWS, so yeah. I don't know if that answers your question.
No, that's great, yeah.
Hi, thank you for the chat. So I just wanted to clarify, understand if we're serving the model from MLKit, the published model, would the user be downloading the model every single time they're connected to a Wi-Fi, or would it cache on the device?
So what it does is it will cache, it will only fetch new models. So it will look at the model and it will say, cool, there's been changes, and the specific user needs to pull these changes. It does make a request, though. It does actually request every single time to check. But from my experience, that's kind of what it does. I've never had a situation where it was downloading those models every single time. Maybe I flipped some kind of like something to true and then it never did it, or it was caching somewhere, but like only when I had models that were, it would send a request because I can see it in the Google Cloud Console. It would do that and then it wouldn't re-download the model.
Okay, one last question.
Thanks. One problem when you start out with this technology is that, like, typically you don't have a big body of images in the beginning. Google insists that they don't even start building a model. You need to have at least 10 images per label, I think. Yeah. Which is already a lot if you're just messing around with the technology. So one trick people use then is take a little video, chop it up into images, but they're going to be very similar in lighting. Like, what's your experience with this? Is there any point trying this, or do you have to collect a bigger body of diverse images before this makes sense at all?
Yeah, so definitely when it comes to images, you kind of have to have as many as possible. They actually say you should have 1,000 per label before actually training something. So obviously I had a very small data set. Something that we did with this is that we kind of take the image, whatever it is, the thing, and then we make it a white background. So you saw all the images had white backgrounds because there was also the whole thing around, there was a guy that trained this model, and he trained it with like huskies in snow, right? And what happened was that he trained this model and it was great, and then all of a sudden, like he put a human that was in snow without knowing. He was like, oh, let me train this thing let me see if it can recognize that it's not a human. And it still said that it was a wolf that was in the thing. And what it did was it was actually just training because the thing that it looked at was the snow in the image and not actually the actual wolf. So what we do is kind of just like clear all the images out there, and yeah, that's kind of what we do.
Thank you so much, PJ. Can we just
thanks.
give PJ one more round of applause, please?